When a beam of light hits a piece of glass straight on, it passes right through it. But the waves that make up the light actually get slowed down by the glass and only go back to their normal speed when they come out the other side. That slowing down is what causes white light to split into a rainbow of colour whenever it hits glass on an angle. It happens because glass slows some colours of light more than others, and because slowing down on an angle makes light bend. It's easy to understand the bending if you picture how the light waves would look from above, like how waves at the beach look if you see them from the air. And while white light's made up of all the different colours of light, it also helps to look at them one colour at a time. When a wave front of red light hits glass on an angle, the part of the wave that enters the glass first gets slowed down before the rest, and that changes the angle of the whole wave, like how waves bend around a cliff. Violet light gets slowed down even more by glass, so its waves bend more. All the other colours get bent somewhere in between. So the colours get separated when they first enter the glass on an angle, and they spread out even more when they speed up on an angle as they leave. The reason the different colours slow down different amounts in glass is because they've got different wavelengths. Red light has the longest wavelength, followed by orange, yellow, green, blue, indigo, and finally violet with the shortest wavelength. And the shorter the wavelength, the longer it takes to travel through glass. That's because light interacts with electrons in the molecules that make up glass. Long wavelength light, like red, only interacts a bit with the electrons, so it doesn't get slowed much. But shorter wavelength violet light interacts more, so it gets slowed down more. So it's the combination of hitting glass on an angle and different wavelengths interacting with the electrons in the glass different amounts that makes light hitting a prism spread out into a beautiful spectrum of colour and some classic album cover art.
Today we are going to talk about Lesson 2 in Unit 2, the wave nature of light. At first, we have to know what is the meaning of light. It is an external factor which affects our eyes and causes the sense of vision. What is the meaning of the sense of vision? It means is that how can we see the things or the objects around us. So what is the meaning of light? It is an external factor which affects the eye and causes the sense of vision. Secondly, we have to know what is the definition of light speed. Light speed, it is the distance which covered by light in 1 second. And we have said in the previous lesson that its speed of light 3 by 10 power 8 meters per second. And light is from electromagnetic waves. Electromagnetic waves. What is the meaning of electromagnetic waves? It means that light can propagate through vacuum or through space because it is an electromagnetic wave. So the speed, it is the distance divided time. Distance divided time. Now we have to know what is the meaning of visible light. It means that there is a light that we can see, and there are some lights that we can't see. As infrared, it is a light waves, but we can't see it. As ultraviolet, it is also a light, but we can't see it. But the visible light, which we can see, it is one of the components of the electromagnetic spectrum of wavelength range between 380 up to 700 nanometer. The wavelength of these waves that we can see, its range is between 380 up to 700 nanometers. And as we know that the sun is the main source of light on Earth. It is the main source of light on Earth. Today we have to know that the white light, as you study in the previous years, that the white light consists of 7 spectrum colors. طب how can we separate or analyze this white light? We can use the glass prism which separate or split or analyzes the white light into 7 spectrum colors. So the white light consists of mixture of 7 spectrum colors, which are known as the spectrum colors. Each color has a certain frequency. Each color has a certain frequency. So these colors are red, orange, yellow, green, blue, indigo, and violet. These are the 7 colors which the white light is consists of. As you see, this is the glass prism which separates the white light which is produced from the lamp or from the sun into 7 spectrum colors. You have to know this arrangement: red, again, red, orange, yellow, green, blue, indigo, violet. When the white light falls on this triangle glass prism, it analyzes into 7 spectrum colors. The colors deviate with different angles. Each color has to deviate with angle different from the other color. So, as you see, the red color has the lowest deviation, but the violet color has the highest deviation. What is the meaning the lowest deviation of the red color? It means that it has the lowest deviation, so it is near the apex of the triangle glass prism. But the violet has the highest deviation, so it is near the base of the triangle glass prism. Also, the red color has the lowest deviation and the lowest frequency, but it has the highest wavelength. But the violet color has the highest deviation, the highest frequency, but it has the lowest wavelength. So again, the red color has the lowest frequency, the longest wavelength, the lowest deviation. What is the meaning of the lowest deviation? It means it is the closest to the glass prism, to the prism apex. But the violet has the highest frequency, the highest deviation. It means it is the closest to the prism base, but it has the shorter wavelength. Again, we have to know what is the spectrum color with constant speed and different N. All the spectrum colors move with constant speed. As we say in the beginning of the lesson, the speed of light 3 by 10 power 8 meter per second. All of them has the same speed, but they are different in 1. The wavelength, the frequency, and the angle of deviation. As you go down from the red to the violet, you find that the frequency increases, but the wavelength decrease, and the angle of deviation increase. So as we go from the red color to the violet color, the frequency increase, the angle of deviation increase, but the wavelength decrease. We have known that energy of light, or the scientist Max Planck discovered that the light has energy. The physicist Max Planck proved that the light waves consist of energy, which is called the energy quanta. This energy quanta is called photons. So when you hear the word photons, you know that it means the energy of light. The word photon means the energy of light. The energy of the photons is directly proportional with its frequency. That means that by increasing the frequency, the energy of the photons increase, and by decreasing the frequency, the energy of photons decrease. We have taken the red color has the lowest frequency, so it has the lowest energy photons. But the violet color has the highest frequency, so it has the highest energy of photons. Max Planck put it as a rule, and it says that the energy of photon equal a constant, and this constant is called related to Max Planck by Planck's constant by the frequency. So the energy photon of these colors equals the Planck's constant by the frequency of such color. The energy photon of the red light is smaller than the violet light. Give reason why? Because the energy photon is directly proportional to the frequency, and the frequency of the red is less than the frequency of the violet. So the energy photon of red is less than the energy photon of light. So when we make a compare between red light and violet light, we find that the frequency of the red is the lowest, the energy photon is the smaller, and the deviation is the lowest, but it has the only longest thing is the wavelength. But in comparison with the violet, we find that the violet has the highest frequency, the highest energy of photon, the highest deviation, but the shortest wavelength. Thank you, dear student, today for listening for me.